In this video, we are going to discuss first order linear differential equations. First order means the order is 1. That means there's only dy dx. We don't have the second, third, fourth, or higher derivative. So first derivative equation is involving the first derivative. And linear differential equation means dependent variable and its derivatives appear in the linear form. They are not product or square of, we don't have y times dy dx. Y square is not there, so dependent variable and its derivatives appear in the linear form only. First order linear equation has the general form y prime plus p of x times y is equal to q of x. So that means we have dy dx plus a function of x times y equal to another function of x. P of x and q of x are either functions of x only or they can be constants. Steps to solve will be write the equation in the form here. Sometimes the given equation is not in y prime plus p of x y is equal to q of x form, so we want to write it in that form first. Second, find the integrating factor, e raised to the power integral of p of x dx. Remember, the sign of p of x stays with it. If we have a negative sign here, that will go in front of the integral when we find the integrating factor. If it's positive, then that would remain positive. Next step, multiply the equation both sides with integrating factor. And then step number 4, integrating factor times y on the left side would be equal to integral of q of x times integrating factor. Let's see some examples, and hopefully you will see how and why does this rule work. Why does multiplying with integrating factor works? Here's first example. Y prime minus 2y is equal to 6. So let's first check. Is it of the form y prime plus p of x times y is equal to q of x? Yes, it is in that form. It is first order linear differential equation. First order linear differential equation. First order linear differential equation. Okay, so let's start by thinking about the integrating factor. What's going to be the integrating factor in this case? Integrating factor is e raised to the power integral of p of x dx. P of x in this case is the number that multiplies with the y. In this case, it's negative 2. So it's going to be integral of negative 2 dx, negative 2 dx. Negative 2 dx. And that would be e to the power negative 2x when we do the integration. Now we're going to go ahead and multiply everything on both sides with the integrating factor. Multiply with integrating factor. So y prime e raised to the power negative 2x minus 2y e raised to the power negative 2x equals 6 times e raised to the power negative 2x. All right, so that will leave us with, now if you look carefully, this is the left hand side is derivative of y and the integrating factor. So derivative of y and the integrating factor, that's what we have on the left hand side, and the right side is 6 times e raised to the power negative 2x. Now when we do integration both sides, when we integrate, derivative and integral are opposite of each other. So left side we are only left with y times e raised to the power negative 2x. The right hand side would be 6 times e raised to the power negative 2x divided by negative 2 plus a c. Now one thing that's important to note here is go ahead and apply the product rule on y times e to the power negative 2x. That would be the first function times derivative of second, which is going to be y times e to the power negative 2x times negative 2, plus second function, which is e to the power negative 2x, times derivative of first, which is y prime. So this is the product rule, opened up product rule. That's what we see here. So we wrote it as derivative of the product rule. Derivative of the product rule. All right, simplification a little, and I think we're almost done. We are ready to isolate the y here. So y is going to equal, this is going to be 3, negative 3. Y would be, let me do one step at a time. That would make more sense. Y e raised to the power negative 2x equal to negative 3 e raised to the power negative 2x plus c. Divide everything with e raised to the power negative 2x, negative 3 e raised to the power negative 2x, e raised to the power negative 2x plus c e raised to the power negative 2x. These we can cancel. Y turns out to be negative 3 plus c e raised to the power 2x, and that is our solution general solution to this equation. We can find particular solution if we are given an initial condition, but in this case we were not given an initial condition. Let's check out another example. Y prime minus y minus x e to the power x equal to 0. Let's put it in the nice shape and form. Y prime minus y is equal to x e to the power x. We can think of it like this. Now we can see these p of x and q of x are functions of x only. So this is first order linear differential equation. Okay, now we are going to find the integrating factor. Integrating factor will be e raised to the power integral of p of x dx, which is going to be negative 1 dx. That turns out to be e raised to the power negative x. Now I'm going to multiply everything on both sides with e to the negative power x. E to the negative x y prime minus y e to the negative x is equal to x e to the power x times e to the negative x. Remember to multiply both sides of the equation with the integrating factor. Okay, now the left hand side, if you look carefully, this is the derivative of y times e to the power negative x. You can go ahead and do the product rule here. It would be first function times derivative of second, which is y times e to the power negative x times negative 1, plus second function e to the negative x times derivative of y, which is y prime. So that's what this is. This is backwards product rule. And the right hand side, e to the x times e to the negative x will be e to the 0, which will be 1. So just x left on the right hand side. Now when we integrate on both sides, that is going to leave us with derivative and integral are opposite of each other. So I'm going to integrate on both sides, and that's going to leave us with y e to the power negative x is equal to x squared over 2 plus a c. Okay, x squared over 2 plus a c. And finally, we are ready to isolate the y. X squared over 2 e to the negative x plus c over e to the negative x. Now we can write it as y is equal to x squared over 2 e to the power x. We can take to the numerator and make the exponent positive, and that's going to be our solution. Again, it's a general solution with arbitrary constant c involved. Next example, xy prime plus y equals 6x squared. Again, is it first order linear? Y prime plus p of x times y equals q of x. Yes, it is. P of x is 1 in this case. Actually, not yet, because we don't have y prime by itself. So we do have something sitting in the front. We will divide everything with an x. That would make y prime plus 1 over x times y is equal to 6x. Now it is in this form, first order linear form. Integrating factor will be e integral e raised to the power integral of 1 over x dx. Turns out to be e to the power natural log of x, which is just x. Now multiply everything on both sides with the x. Xy prime plus 1 over x times y is equal to 6x squared. Xy prime plus y is equal to 6x squared. Now if we look on the left side carefully, this is derivative of, this is going to be the derivative of two functions, which is x and y. If I perform the product rule on derivative of x and y, if you perform the product rule, that is going to be x times y prime plus y times 1. And the right hand side we would integrate. It will leave us with xy is equal to 6x to the third over 3 plus a c. We can simplify here. Xy equal to 2x to the third plus c. Lastly, y is equal to, divide everything on both sides with an x, 2x squared plus cx to the power negative 1. So y equals 2x squared cx to the power negative 1. And that's our solution in that case. Let's see one more example. We have y prime plus 1 over x minus 2y is equal to x plus 2. First of all, let's see if it's first order linear form. Yes, it looks like this is a first order linear form. This is my p of x and this is my q of x. It does look like a first order linear form. So I'm going to go ahead and find the integrating factor. Integrating factor would be e integral of p of x dx. E raised to the power 1 over x minus 2 dx, which will be e natural log of x minus 2, and that's going to be just x minus 2. So we will multiply everything on both sides with x minus 2 y prime plus 1 over x minus 2 times x minus 2 times y, x plus 2 times x minus 2. Cleaning up left hand side, x minus 2 times y prime plus y is equal to x squared minus 4. Now if you look carefully, the left hand side is the derivative of product rule, and when we do integral, product rule applied on q of product rule applied on y and the integrating factor. Y and integrating factor. So this is going to be y times the integrating factor, which is x minus 2, and the right hand side we can do integral. So we have the derivative on the left hand side. When we do the integral, derivative and product rule turns out to be y times x minus 2. And if you go ahead and do the derivative here, y times x minus 2, it would be x minus 2 times y prime plus y times 1. So that is correct. So we are doing integral in the next step. And left hand side, we're just left with y times x minus 2. And the right hand side, we have x squared minus 4 dx. Integral of y times x minus 2. This would be x to the third over 3 minus 4x plus a c. Last step, we are going to divide everything with x minus 2. And that should be x squared minus 4. That looks x cubed, yeah. That's fine. 1 over x minus 2, x to the third over 3 minus 4x plus c. And that's our solution in this case. See one more example of first order linear differential equations. We have dy over dx equal to x squared minus y over x. Definitely not in a good shape because we want to have y prime plus p of x times y is equal to q of x. This is the form first order linear equation has to be. So let's go ahead and try to. There's many type of differential equations. There's homogeneous, there's separable, there's first order linear, there's higher order equations. So this technique only works on first order linear equation when it's written in this form. So our goal is to try to write it in this form. I'm going to write x times dy over dx is equal to x squared minus y. X dy dx minus x squared plus y is equal to 0. Or x dy dx plus y is equal to x squared. I'm just rearranging to make it look nice, and I want it to look like that. I want to have derivative y prime plus a function of x times y equal to a function of x. Okay, now I do need this x to go away from here, so I'm going to divide everything with an x. Turns out to be dy dx plus 1 over x times y. Y over x is same thing as 1 over x times y equals x. Let's go ahead and find the integrating factor, which is going to be e integral of p of x dx, e 1 over x dx. That will be e natural log of x, which is just going to be x. Go ahead and multiply everything on both sides with an x. X dy dx plus 1 over x times y is equal to x squared. We can cancel these. All right. Now, if you look on the left-hand side, this is the derivative rule, product rule applied. So this is the derivative of product of x and y. We are going to integrate both sides, and that's going to be derivative and integral are opposite of each other. So left-hand side would be only xy, right side would be x cubed over 3 plus a c. Y turns out to be x cubed over 3x plus c over x, which leaves me with y is equal to x squared over 3 plus c x to the power negative 1. And that's our final solution and our last example for our first order linear equation. Again, the steps to solve are, first of all, make sure you recognize it has to be in this form. If it's not, it's probably not a first order linear equation. So in this course, we're only talking about separable and first order linear. Those are the only two types of differential equations we are going to solve. First of all, write the equation in this form. Second, find the integrating factor, which is e raised to the power integral of p of x dx. Very important that the sign of p of x goes with p of x in the integral, in front of the integral. If it's a negative sign here, so if we have a negative sign here, that negative will go in front for the p of x. Then multiply both sides with the integrating factor. Next step, your left hand side would be integrating factor times y, and the right hand side would be integral of q of x times integrating factor. And then from there we can solve the equation by performing the integration.